The skiers start the race on a platform above the snow. Now the round starts. They are using their poles to push themselves off the platform and onto the snow. Wow, look at them go. The moves are almost exactly the same. Now they are on the first uphill. Let's slow this part down. Notice that they all use the poles to push backwards at the same time. The first time they are going down from the platform, the second time right after hitting the snow, the third time right before the end of the uphill region. The reason they do this is to increase velocity in a wanted direction. When the poles push onto the ground, it provides a force going in direction A. According to Newton's second law, the ground provides the same amount of force onto the poles in direction B. An additional forces increases velocity, and here as the skiers are holding the poles, they will gain velocity. The skier can control the direction of acceleration by simply changing the direction of the forces exerted on the poles. In this clip, a skier is trying to slow down. Notice that the poles are in opposite direction to his movement of going downhill. This provides a force backwards and therefore lowers his speed. Now, in this clip, the skier is traveling uphill. His poles point backward while he goes forward. The race continues. As they gain speed, it almost seems like they're flying on the snow. In fact, has anyone ever wondered why skiing is on snow? Let's watch a few examples where people ski on something that's not snow. This is a really bumpy ride. The stairs have lunge bumps that make the ride uncomfortable. Sand works for skiers almost as well as snow. Turns out they are both types of textures that don't have much friction. Friction increases when the roughness of the surface increases. More friction means you have to put in more energy for the same results. Snow used for skiing decreases the amount of energy needed, making it easy for them to gain speed. But remember that a decrease in friction can also maximize errors sometimes. The four skiers make a few more turns. Wait, one of them tripped and fell. He managed to drag another skier along with him. I'll go back and slow down this place. As he is going down this hill, he stretches out his arm. This is the problem. As the skier stretches out his arms, his center of mass shifts upwards. As he is landing, because his center of mass is further from the ground, it is easier to trip and fall. An object's center of mass is a point where you can balance the whole object. Therefore, when landing on the ground, this skier loses her balance and trips. Now, there are only two people still racing. One of them slowly takes the lead. Now the track is basically made up of big hills and big curves. How does one take the lead when their moves are almost the same? It will be made possible when one gains more velocity. When the skier leaves the hill, he or she is only exposed to air resistance. Then he or she soon hits the ground. Like a normal baseball, if you throw it up, it will eventually come back down. The skier here is the same. After leaving the hill, they sail in the air for a few seconds and fall back down. These motions are called projectile motion. To help us understand projectile motion and how it affects velocity, let's look at an equation. Gravity will never change, and the angle of the jump is controlled by the hill. So the one thing that skiers can manipulate is the initial velocity. The higher your original velocity is, the more distance you can travel in one projectile motion jump. Although unstated, the air resistance also changes things. Bigger objects have more air resistance, lowering their speed. Therefore, a skier that takes the lead has to be better at keeping his air resistance low or has a faster initial speed. And they're near the finish line. Finally, one of the skiers passes the line and wins the game. Usually we can just cut the video here and call it an end, but the process of how a skier stops is also important. A successful stop is when a skier can transform all the kinetic energy into potential energy. An object always has energy. Potential is the type of energy that occurs when you are not moving. Kinetic is where you are moving. In order to achieve the shift from kinetic to potential energy, the skier has to use friction to force this change to happen. Here, the skier tripped, so she did not have time to stop herself, and she ran directly into a board. Here, the skier kept his balance, as well as did a good job in using friction to slow himself down.